And dear students, today we will solving about the problem of exercise 1.6 from the 9th class students. Let's come we start exercise 1.6, important question for the board. Exercise 1.6. Question number first part to 1, x plus 2y is equal to 1 and 2x plus 3y 5 over 3 using inversion method. 5 by 2, 5 by 2. Now using by inversion method, first of all we write the given system into the matrix notations. Symbolically we write by metric notation. So the given system can be written as in matrix notation. First of all, we are required the given system and matrix notation. How we can write? Now we are taking the coefficient of the variable x, 1, 2, 2 and 3. X and y is equal to 1 and 5 over 2. Now here we give the name of the matrix of each matrix. Let suppose that A is equal to 1, 2, 2, 3 and x represent small x and y because we are finding the value of x, and B is equal to 1 and 5 over 2. Now according to the matrix notations by inversion method, so we are required the formula using inversion method. Inversion methods, we know that Ax is equal to B. It means that if we multiply the inverse A inverse on both sides of this one, so A inverse B. So this result we know that A into A inverse must be equal to identimetric. So this will be identimetric and we get A inverse B. It means that we are required x is equal to A inverse B. We give the name equation number first. So first of all, we are required A inverse. If A inverse is exists, then we are further solution is possible. It means that it will be a singular matrix, so the further solution is not possible. Then we cannot proceed to the further solution. Now we write the solution of A inverse. A inverse is equal to 1 over A determinant adjoint of A. This will be in the second equation. Inversion method is also used use, for example, in the paper is question is changed using an adjoint method. Adjoint methods. So there will be no confusing. It means that we are using this method. Here, here A determinant is equal to AD minus BC. This is the general formula because here A, B and C and D, the matrix form are A, B and C, D. We put the value of A determinant AD minus BC. So we can write here A is equal to 1 and D is equal to 3. Similarly 2 and 2, we get answer 3 minus 4 is equal to minus 1. Minus 1 is not is equal to 0. It means that it is a non-singular matrix, so A inverse exists. You can write here since A inverse exists because it is a non-singular matrix. Non-singular matrix means the determinant of any matrix not is equal to 0. Non-singular matrix, so A inverse exists. Now we are proceeding to we are finding adjoint of A. What is the value of adjoint of A? So the value of A and D are interchanged to each other. So we put here D and A. And replace of A we put D and replace of D we put A. So these are the values replace are just changed. But here of this the sign of B and C are the sign is changed. So we write here minus B and minus C. This is called adjoint of A. Now we put the values of in the place of D we put 3 and similarly here minus 2 and minus 2 the sign is changed. In the place of A we put here 1. Now put these results, put the values of A and adjoint of A in equation number 2nd. We get what is the result? A inverse is equal to 1 over A determinant. A determinant is equal to minus 1. Adjoint of A 3, minus 2 and minus 2 and 1. Now we divide each value by minus 1. So the sign is also changed here. 3 divided by minus 1 we minus 3 minus 2 divided by minus 1 plus 2. Similarly here minus 2 divided by minus 1 plus 2 and 1 divided by minus 1 we put minus 1. Again we put this result in equation number first. Again put A inverse in equation number first. We get x is equal to A inverse B. This is the first equation. We put the values here. X is equal to x and y, and A inverse we have already done. Minus 3, 2 and minus 1, and here B is equal to 1 and 5 over 2. This is the value of B. Now according to the multiplication rule, first row and first column we multiply this one 3 minus 3 and 2 1 plus 2 multiplied by 5 over 2. Similarly the second row we multiply 2 multiplied by 1 plus minus 1 multiplied by 5 over 2. Now expand this term, minus 3 multiplied by 1 minus 3 and 2 is cancel here. We get plus 5. Similarly here 2 and plus into minus minus 1, 5 by 2. Here we get minus into plus, minus 1 multiplied by 5, 5 over 2. Now we are taking here LCM. Is equal to, now we subtract this one, minus 3 plus 2, we get 2, and here we take 2 is the LCM, 2 multiplied by 2, we get the answer 4, 4 minus 5, and 2, and minus 1 divided by 2, means that here x is equal to 2 and y is equal to minus 1 over 2. This is the solution of the unknown variables by inversion method. Now we want to verification our answer is correct or not. Verification. You can do, if you have time in the paper, you can check your answer by verification methods. So we have know that x plus 2y, we put the values x plus 2y is equal to 1. We replace by equation number first the given values, in the place of x we put 2, and 2 into minus 1 by 2, so is equal to 1. So this will be cancelled, 2 and 2 plus minus 1, so we get here minus 1 and 1 is equal to 1. It means that our solution is correct. So solution set is equal to 2 and minus 1 over 2. This is the value of x and y. Now we are using by the second question number 2 part 3. These are the important questions. 5x plus 7 is equal to 3 and 3x plus y is equal to 5. Follow the system by Cramer rules. By Cramer rules, we are using the method of Cramer rules. The first we are write the given system in matrix notation form. So we can write the given system can be written as in matrix form so we write the coefficient of the variable x and y 5 and 5x plus 7y, and here is 7y plus 7y 3 and 1 x and y, so 3 and 5. Look here, if we multiply these two terms, we get the same one. 5 multiplied by x, 5x plus 7 row multiplied by column method. So the given answer, the given system we obtain. So now we take the supposition, let a is equal to 5, 7, 3, 1, and here x is equal to small x and y, and b is equal to 3 and 5. Now we are using the method of the method of Cramer rule. X is equal to ax determinant divided by a determinant. Similarly, y is equal to, this will be small x is required because we are needed the value of y, and here ay is equal to a determinant. We are required these two values by Cramer rule. The first of all we are needed check the system is exist or not. So we are needed a determinant. First of all, we are required a determinant. A determinant we can write here also 5, 7, 3 and 1. Or we can say that AD minus BC is the general formula. Here A is equal to 5, B is equal to 7, and C is equal to 3, and D is equal to 1. We substitute in the formula 5 into 1, 7 into 3. So what is the result? The results we obtain 5 multiplied by 1 5, and 7 multiplied by 3 we get 21. So the answer we get here minus 16. 16. It means that it is not equal to 0. So A inverse exists. Here A is a non-singular matrix. Here A is a non-singular matrix. So A inverse exists. It means that further solution is possible. Now we are required here AX. Now what is the AX? AX means here we change the first value of the X value, the first column change by the replace B values. It means that here we change 3, 5 and 7, 1. Now we change 3 into 1, 7 multiplied by 5, so we get 3 minus 75, 35, and we get here minus 30. So similarly, if we change here and A and Y, so we change the Y values replaced by B values, but means that here 7 1 is replaced 5 3 and 3 and 5. So the same formula we are using AD minus BC. Here 5 into 5 and 3 into 3. So here is 25 minus 9. So we get 16. Now put the values in the above Cramer rules formula. We get here the value is minus 30 divided by here is minus 16. So we get the answer 8 and 15, 15 over 8, and similarly y is equal to, and here is 16 divided by minus 16, so we get the answer is minus 1. Now we check your answer by verification method. Thank you very much once again for watching, and please subscribe my channel. Once again, thank you.